Okay, welcome to today's webinar titled Best Practices for the HPC Hybrid Cloud, sponsored by Univa. I want to thank you for joining us, taking time out of your busy schedule. My name is Gary Tyerman. I'm the CEO of Univa, and I will be your moderator today. Throughout our presentation, we encourage you to interact with us, asking questions, comments, using the question window. We will have an open Q&A session right after the main presentation. We'll set aside enough time to make sure we handle all the questions. Our presenter today is Ian Lum from Univa, and I will introduce Ian in a few moments. And first, what I want to do is talk a little bit about Univa, just one slide real quick. Univa is the largest innovator and independent provider of cluster management and orchestration software today. We are an innovator in software-defined computing infrastructure solutions in HPC, cloud, and Kubernetes clusters, with about 250 customers weighted to the enterprise with about 2.6 million compute cores under management. Our product, Grid Engine, is a leading workload management product in multiple industries, such as life sciences, and is the de facto standard and primary choice of workload management today in HPC cloud. Today, we will cover some aspects of the migration of workflows to the cloud. The shift to cloud, as many trends in the data center are, is motivated by IT agility and efficiency. Today, Ian will walk through some recent Univa open source activities and a case study of organizations that have successfully migrated workflows to a hybrid cloud. Then we'll look at a modern approach with cloud-native HPC, which ties directly to the quote on the screen here from Gartner about how compute infrastructure is rapidly becoming software-defined and composable. First, let's get grounded in some perspectives on the market. I mentioned earlier that Univa's customer base is weighted to enterprise, roughly 80% in terms of count and in terms of revenue. 2 years ago, if we look back, we saw very little interest in cloud. It existed in certain areas of our customer base and certainly in the market, but it had not become a key objective for enterprise HPC IT teams. In the last year, interest in cloud in our customer base has grown tenfold. We just completed a survey of our customers, which is shown on the right-hand side of the screen, which showed 61% of those surveyed are open to cloud. That means they are considering, they are evaluating, planning, or have already deployed to the cloud. In fact, 16% of those surveyed have already deployed workflows to the cloud and are using it regularly. This contrasts to roughly 10% of our customers that were open to cloud in a prior survey over a couple years ago. This remarkable growth is a key reason why Univa open-sourced Tortuga, the HPC cluster management framework that underpins our product, Navops launch. Our motivation is to help accelerate the migration of workflows to the cloud by providing a horizontalized capability to all HPC users. Ian will speak to the details of Tortuga in a few moments. We have also noticed that software-defined approaches to IT in general IT, including containers and cloud, is having an impact on HPC infrastructure. Ian will speak to our cloud-native HPC approach as a means to modernize IT, as well as a case study. But first, here's a few more data points from our customer survey, which literally finished last week. The top 3 applications deployed to the cloud are, probably not very surprising, HPC, AI, and big data. In the definition of HPC, which is a broad term, we're not specifically referring to parallel or MPI applications, rather all applications that encompass the generalized market of HPC. That could include parallel, that could include serial throughput and very short running jobs. But this maps directly to the industry filter that we applied to the survey, which in the bottom graphic shows life sciences, academia, aerospace, EDA, tied with energy as the large or the top industries looking at and considering cloud. In terms of cloud use, for those who are experimenting, planning, deploying, or actually deployed already, Amazon has a commanding share, followed by Azure, Google, and Oracle. When we asked what the organization planned to use, which could be the same as testing, the results were a little surprising, with Amazon share increasing as shown. The flip side is those who are not considering cloud. Multiple reasons were cited, and of course, multiple reasons could be chosen rather than a fixed set. but many are not new, nor are they really surprising. Cited most often is the security of data, followed by an admission that there is a lack of cloud expertise within the organization, as well as legal or regulatory issues. With respect to skills, we see this as a growing concern in general in enterprises, which we will see on the next slide. Not related to our survey, but through observation across conversations with customers and prospects, we look at key drivers to migrate to the cloud. While life science businesses have access to large common and shared data, which improves their motivation, we can see some common drivers across multiple industries. The number of, the skill of, and the cost of HPC admins is a daunting concern and a key motivator. Internal capacity, wait times for users, and the desire to service users who otherwise would wait a very long time is also fairly representative. This list that I'm showing here has been filtered via the industries from our survey, and as I mentioned earlier, these are the top 4 industries that would are in and using HPC Cloud. Now I'd like to introduce Ian Lum. Ian received his Bachelor of Science from Montreal's McGill University, then a Master of Science from York University in Toronto. Although his undergraduate and graduate studies emphasize geophysics, Ian's current interests include workload orchestration, container, and optimization. Ian will cover Project Tortuga, Navops launch, a comparison to do-it-yourself, and we'll walk through the Wharton case study and close off with an overview of a modern approach to infrastructure with cloud-native HPC. Ian, over to you.
Well, thank you very much, Gary. As Gary's mentioned, there's a real emphasis today on our discussion of hybrid cloud, and that's where we're going to place our emphasis today, even though I do want to just point out that we certainly can have conversations where we look at putting an entire environment completely in a cloud, whether that be a private cloud or a public cloud. We can bridge clouds together in various ways and so on. But really, our emphasis today is to talk about hybrid cloud. And I'll frame that a little bit more clearly for you as we delve into some more of the content from within the webinar today. Now, Gary mentioned Project Tortuga. This is a very recent announcement that we've just made. We're quite excited about this. And as you can see, what we have put into the open source community is basically a general purpose cluster cloud management framework. And it is able to address that broad swath of applications and environments that Gary's alluded to in various ways through his opening remarks. Now, of course, to really tap into the cloud, automation is absolutely key, and being able to automate not only the on-premise capabilities, but also what might happen in the cloud, and certainly that applies to hybrid configurations. The details of the Tortuga framework are shown here on this particular slide, and as you can see, there's quite a lot to this. Really, we need to address a number of considerations. So obviously, we have to integrate with whatever is available in terms of the API that's provided by one or more cloud providers. So there's a need to integrate with that. And a big part of the value that we offer through Tortuga are what are called resource adapters. These are cloud-specific adapters that allow us to work with the various cloud providers, and you can see some examples in the resource adapter section of this particular graphic here, the schematic, as well as via the logos that we have down at the bottom of the screen. And that's by no means an exhaustive list. We've listed the typical public cloud providers in this slide because that's what we're seeing from our interest in our customer base in terms of building hybrid cloud configurations. But we also do support OpenStack as well. In terms of some of the details with respect to the Tortuga framework, we take advantage of Puppet for configuration management. We have provided various APIs ourselves, including a REST API, and we provide various standard services that you'd expect to see, such as name service resolution, and if you happen to be working with physical nodes, other services that would be appropriate there. We mentioned that we've actually open sourced Project Tortuga on GitHub. So these are the details, and just a heads up that we will share information like this with you as a follow-up to the webinar, so there's no need to try to copy down these rather lengthy URLs. It's important for me to point out that this is actually not an isolated act in terms of Univa open sourcing some aspect of its technology portfolio. We have a number of other examples that you can also find on GitHub, but let's focus on Project Tortuga today. As you can see, we've made it available via an Apache 2.0 license, and we've made available the core capabilities of Tortuga, but also some, I think, some rather compelling components. Included in the open source offering are adapters for various different cloud providers. And again, I encourage you to look at the list of adapters that we've made available there. So it includes all the usual suspects that we highlighted on the previous slide. So what this means, of course, is that you can actually go onto to GitHub, clone this particular project, and start working with it yourself. We've made available basically a kit that highlights the integration between the integration components with Univa Grid Engine, as well as our Unisite product, which is able to provide monitoring and reporting capabilities. And we'll talk a little bit more about some of these additional features as we delve into the material in the rest of the slides. Now, what we've also been finding is that many people are considering the do-it-yourself option, so DIY, do-it-yourself, in terms of their approach to wanting to make some kind of an entree into a cloud computing environment. And of course, this is a very reasonable thing to think about, but the reality is that if you actually delve into this, to get to the point of reproducing the kind of breadth and depth that we've already made available via this open source licensing scheme in Project Tortuga, you're probably looking at about of order 100 days, and that's for somebody who's actually quite experienced. So we actually think that that's almost a best case scenario estimate, is you'd be looking at about 100 days worth of effort. And what you'd end up doing then in proceeding in a fashion like this is very likely developing what we would consider to be a bit of a one-off solution. In other words, it might be very cloud provider specific, very application specific, and if you needed to revisit that to take into account a different application, a different cloud provider, you might find yourself repeating that same process almost in its entirety. So it's not likely to be a very reusable effort. So there is some real consideration to be given here. And unfortunately, what we find is that a lot of organizations don't actually find this out until they're well into the situation, and then realize that just exactly how much is actually involved. I'm going to be talking shortly about our Navops launch product. And if you were to take what we've got in Tortuga and build much more of a scalable solution that handles multiple cloud providers and is something that you can actually maintain and sustain and really leverage as in terms of reusability and so on, then you'd be looking at well over a year's worth of effort. So the do-it-yourself option is certainly there, but I think if you really, take things into consideration, you realize that there's quite a lot of effort involved. So we do have a very comprehensive product portfolio at Univa. Obviously, we're known for Univa Grid Engine, which in addition to having a very significant presence in the cluster computing area and in the markets that Gary described for you earlier, it's actually also the most commonly deployed workload manager in cloud environments as well, by customers, but also by partners. Even in various projects, it's quite interesting the presence that Univa Grid Engine has, and that's really why a lot of what we're sharing with you today is really well informed by our own actual involvement, experience, etc. We've added on Univa Unisight, which I alluded to before, which really introduces visibility into the workloads that are being managed by Univa Grid Engine by presenting monitoring and reporting capabilities. And then if you need to also manage software licenses, as some of our customers do, we've also got the license orchestration capabilities through Univa License Orchestrator. In addition to the traditional portfolio that you're probably familiar with based around Grid Engine, we've also been working on Navops as well. And as you can see, Navops is actually also a fairly rich offering at this point as well. And I will come back and talk about various components here, but I do really want to speak about Navops launch and use the kind of bridge from open source Tortuga into a discussion of Navops launch as really being the way to assist enterprises in making that transition to the cloud, migrating to the cloud, introducing hybrid cloud, putting in place much more of a cloud native capability. So let's say a little bit about what Navops launch is. So in terms of core capabilities, what we're talking about is the ability to deploy and manage HPC clusters. These clusters can be comprised of, let's call them nodes of a variety of different types, from physical nodes to virtual machines to instances in clouds, or any combination of those kinds of things. And really, again, a key capability of launch is its ability to automate the configuration and management of these nodes. What's really important, and I kind of just, didn't make a huge point of it in some of the architecture slides that we went over before, but really one of the most important capabilities that launch brings, introduces into the hybrid cloud environment is the ability to launch cloud instances, but according to some kind of a sensible policy-based approach. So as one very quick example here, a lot of people talk about, particularly in a hybrid cloud context, the need to be able to burst to a cloud environment in some kind of a sensible fashion. And so that is actually a key capability, a core competence, if you like, of Navops launch. And as we'll see through the case study examples, we'll give you a little bit more of a sense as to those kinds of policy-based capabilities. We'll also touch on some of the deeper integrations with that speak to sort of really HPC capabilities that are essential in today's market and through some of the case study examples. Finally, on this slide, and it may actually be the fourth bullet on this slide, but under the key features, but it's actually one of the most important capabilities. In our experience, no two enterprises are identical, and most of the time when we are introduced into cloud projects, we're looking at very much a so-called brownfield enterprise situation. In other words, there's a existing enterprise deployment, and customers are trying to introduce cloud capabilities into that existing IT infrastructure. Another really key capability of Navops launch is its flexibility, and so we'll speak to that in various ways as we move through some of the other material here. Just very briefly, in terms of the schematic down at the lower part of this slide here, what you can see in the upper right-hand corner of the schematic are is a pretty reasonably complete list of the various adapters that are supported by Navops launch. And I do want to point out that these resource adapters, they're tailored for each of the different cloud providers. So there's no kind of requirement to have some kind of a, a lowest common denominator capability that kind of reduces the effectiveness of the adapters. What I mean is that if, for example, there's some unique capability in one of these cloud providers' offerings, because these adapters are tailored on a per cloud provider basis, we're able to take advantage for your benefit, the unique capabilities of that cloud provider. And so I think that's another extremely interesting and important capability. There's obviously the core of the launch product itself with its RESTful API. We alluded to the policy engine, probably one of the most important capabilities, because ultimately what this comes down to is being able to put in place an infrastructure that allows you to address your particular cloud use case requirements, and then all of the ancillary services, some of which we've alluded to before. So if you put it all together, you get this schematic for the hybrid cloud, and let's face it, this is one of the more complex cloud deployment types, and certainly why it makes sense to partner with organizations like Univa, who've started to create a nicely well-worn, a well-paved path into this hybrid cloud environment. So as quickly as I can, I'll just give you an overview of what we're looking at here. In the rectangle, the gray rectangle that's sort of in the middle third of this diagram here, what you can see is the on-premise infrastructure. So many of our customers are coming to us because they've already got an existing investment in Univa Grid Engine. Often that is an existing investment that is on-premise, making use of the customer's own data centers, and with all of the ancillary components, including their storage infrastructure, et cetera. And what they want to do is start introducing a cloud capability into that existing infrastructure. And so what we're seeing down here in the lower part in this call out that is intentionally intended to look rather cloud-like is the cloud-based environment. So basically the idea then is that by making use of the APIs that are specific to one or more cloud providers, our Navops launch software is able to instantiate compute instances in your cloud of choice, and in fact automate the addition of those compute instances that exist in the cloud such that they become part of your existing infrastructure for, in this particular case, workload management. Meaning that everything from traditional batch to the other types of workloads that we were referring to, the introduction of AI and machine learning and deep learning based workloads, analytics workloads, et cetera. And whether those workloads run in containers or outside of containers, all of these different use cases can now be supported in this infrastructure. Many of our customers are making use, again, of unique differentiating capabilities provided by different cloud providers to extend their on-premise network infrastructures into their cloud of choice, everything from dedicated uplinks to virtual private networks, et cetera. We see a lot of different solutions based on people's needs. And often it's, of course, consideration of the applications that you want to ultimately run in your cloud component of your infrastructure, and of course the related challenges to making sure that data is available as required in terms of moving that, which may involve, for example, moving data back and forth between the on-premise infrastructure and the cloud-based infrastructure. And we've hinted at some of the discussions that happen in those particular areas, and certainly plenty of ample material there for more lengthy discussions. So it's one thing to have a kind of an infrastructural pattern like that for a hybrid cloud on a PowerPoint slide, but of course the most compelling thing is to hear about people who've actually put the pattern into practice and have, in fact, embraced the hybrid cloud infrastructure. One of our longest running customers in terms of use of certainly, of course, Univa Grid Engine, but most importantly in this discussion, Navops launches the Wharton School of Business. This is a business school that is associated with the University of Pennsylvania in the United States. Interestingly, they have a very, very diverse mix of application requirements. And let me just focus in on one particular aspect of the Wharton story. We have a whole detailed case study that gives you much more context for how Wharton is making use of their hybrid cloud. But I think one story will serve to illustrate the point rather well. So they have what they call a HPC computing center. And at this particular instance in time that I'm referring to, it was a pure CPU-based environment. And then along came a Wharton researcher who wanted to basically examine very large patent databases, and they wanted to employ machine learning algorithms, deep learning algorithms, specifically something called natural language processing. And they wanted to use a framework called TensorFlow. It's the most popular framework that's being used in the deep learning context these days. So they wanted to use TensorFlow, and they also wanted to run TensorFlow on GPUs. So in this particular case, Wharton did not have any GPU-based resources within its existing on-premise infrastructure. Fortunately, they were making use of Amazon Web Services, and Amazon Web Services provides GPU instances. So what they were able to do was to take those GPU-based instances that were made available through AWS using Navops launch, introduce those GPU-based instances as CUDA-based compute nodes. So then you have all of the advantages of the entire CUDA stack with basically TensorFlow that has been tuned to take advantage of that CUDA platform. And you put it all together, and you've got now exactly what this deep learning researcher required to analyze data from patent databases using natural language processing. And of course, they were able to deploy all of this very, very rapidly. As you can see from the slide, there are a lot of other points that were introduced through this capability. So very nice complementary. A real proof point that you can make use of the deep integrations on the HPC perspective into, for example, the CUDA capabilities that are provided by NVIDIA GPUs, and use that to support a researcher who needs to engage in what is basically a brand new application paradigm at this particular business school. Let me also share a little bit more in terms of some of the details about the Wharton Hybrid Cloud, and using their own words, and specifically the words of Gavin Burris, who's quoted here at the bottom of the slide, Gavin is a senior project leader at Wharton. And again, these are just some of the points I wanted to highlight for you that are perhaps not drawn out quite as explicitly through the case study, because some of these get into more specific technical details. So again, and the emphasis on existing here is ours, but we do want to emphasize that because a key attribute of Navops launch is its flexibility that it presents, which means that these resources in the Wharton case, in AWS, and even the GPU-based instances, they were able to be added in a very seamless fashion to an existing environment, which means that from the user perspective, we are presenting an enhanced environment in a very, very transparent fashion. There's limited learning that needs to take place, additional learning, if you like, on the part of the end user. They get to continue to use things that they are familiar with, from how they log on and access their environment, the commands that they use, the scripts that they employ, the applications that they want to use. All of this is made very transparent, even though in the example I was highlighting, you have natural language processing exploiting TensorFlow on GPUs in AWS. The researcher doesn't need to be encumbered with all of those details. Right now, the need to tap into GPU-based deep learning frameworks is considered an outlier by Wharton, but they were able to add that on when the researcher actually required those resources, and only when the researcher required the resources. So really, tapping into the real value proposition that the cloud, in this case a public cloud, can bring to bear. And obviously there are other possibilities as well, such as large memory instances and so on. The tagging that's available in AWS was a value point in terms of chargeback accounting. Again, the policy-based launching of cloud instances, which is a Navops launch key capability, it can be set up such that, for example, when a deep learning workload is launched into for example, a cloud-facing queue, that Navops launch through its policy engine can look at that pending job, or possibly a backlog of pending jobs, and based on just that as a trigger can start to dynamically spin up instances in the cloud, and appropriate instances. In other words, AWS-based instances in this example with GPU capabilities embedded. Bonus points for our Navops launch integration, and in this case, specifically in the AWS case, is with the notion of placement groups. One of the capabilities that's rendered available via AWS, virtual private cloud capability, spot pricing, which allows you to take economics into consideration in various ways, specialized instances. We talked about GPU-based instances, and in this case, Haswell processor instances, et cetera, and so on. And this last point here is one that, it's kind of just introduced here as a last consideration in Wharton's own words here, but this is actually a really important point. The flexibility that we present through Navops launch means that you can take your existing software image. In the case of AWS, that would be your Amazon machine image. If you've already taken some time to build an image like that, you can, in most cases, you can just leverage that image as is in terms of onboarding Navops launch to further automate the introduction of hybrid cloud capabilities. You don't need to start off from a bare metal or bare instance at all. We can work with what you have already. And again, I really do want to emphasize this because it's a real proof point in terms of acknowledging that the enterprise in most cases is very much a brownfield opportunity as opposed to a greenfield situation. Well, there is, in fact, a very much broader and deeper story to all of this as well. What we're seeing is a shift towards consideration of, really reimagining what it means to implement applications in an architectural way that is inherently cloud native. And what that really comes down to is taking into account the fact that you probably want to be considering containerization. You may be trying to shift towards the introduction, the uptake of much more of a microservices-based infrastructure. You may be refactoring existing applications and workflows, or you may be, certainly if you have greenfield situations, you may be looking to embrace microservices as you move forward in the future. Another key part of this, of course, is you need to have the ability to schedule. the containers, or in fact, as we've shown here in the case of this Kubernetes-based container cluster, the pods that are being made available within this Kubernetes framework. So what we've actually done is enabled this in a variety of different ways. And as we say on this slide, we really are rather unique in this fashion. We've been able to take a traditional grid engine and allow you to run your traditional HPC applications, batch applications, whether they be containerized or not, in this particular environment. But then, if you've also decided to, uptake and adopt containerization in various ways, we've taken the scheduling smarts. In simple terms, we've taken the scheduling smarts of Univa Grid Engine, we've put it into a Kubernetes pod, and that is now able to provide scheduling capabilities in a native Kubernetes context, and that's what Navops command is all about. So what this means now is that when you put all of this together, you can run this incredibly broad and deep mixture of applications, as is illustrated on this slide here. Containerized, non-containerized, and so on, with the relatively recent introduction as well of our support for Mesos compliant frameworks through our Universal Resource Broker product. You can also integrate with basically any framework that happens to be also Mesos compliant, so something, for example, Spark. And by the way, we've also open sourced our Universal Resource Broker. You can find it on GitHub as well. Now, what's also extremely compelling when you put all of this together is that we have the ability to take this environment and run it in so many different ways. And that's what we're really trying to illustrate here at the base of the slide. You can run this Kubernetes environment with all of these different applications, with the workload managed by appropriately Grid Engine or Navops command. That can all be facilitated in your on-premise infrastructure, everything from bare metal to virtual machines forward. And then if you make use of Navops launch in the fashion that we've been describing today, you can also introduce the enablement provided by various clouds and create hybrid cloud capabilities. So again, this looks great as a PowerPoint slide, but is there any real substance to this? Is there any reality to this? And we're delighted to share that there absolutely is. We have, as one very recent and actually not that recent, but we have a very compelling proof point with IHME, this basically independent health organization who had a need for exactly the kind of infrastructure that we described kind of architecturally on the previous slide. In other words, they had just a phenomenally diverse range of applications and workloads, and they are innovating in a very, very compelling fashion, and as a result, they needed to have an infrastructure that was able to move with them and to really address their evolving, in some case, very rapidly evolving requirements. So rather than break down their on-premise infrastructure into silos of, HPC and Kubernetes and machine learning, et cetera, through use of this highly converged solution that we described on the previous slide, Cloud Native HPC, they're able to, IHME is able to take advantage of all of this together. So again, much more than just PowerPoint slides. People are actually putting this into practice, and there absolutely is a case study that would allow you to get additional information on this particular use case. Well, we do want to bring it back to our discussion of best practices, and I'm just going to highlight some points here very, very rapidly. Certainly no two enterprises are the same, and that certainly applies to cloud projects, even cloud projects that might exist within a single organization. What we're seeing as well, and I think Gary alluded to this a bit, is that organizations are finding very clear motivation from the business perspective for the introduction of various cloud capabilities, and these same drivers are quite often driving this interest in deploying hybrid situations. But the hybrid situations do require some project management. And these are just some of the best practices based on our own experience. It really can be beneficial to have project management capabilities introduced into your cloud initiatives from the outset. And again, these are just some of the points that we've and I personally had the occasion to be a party to, shall we say. So we have plenty of experience in this area, and again, some ideas as to how this transition can be made even more seamless. Well, we always like to leave you with next steps, and again, don't worry about copying down these rather complex looking URLs. We'll absolutely be sure that we will send these off to you as a follow-up for you kindly spending some time with us today on this webinar. Certainly, there are many different jumping-off points, and this is in no sense meant to be an ordered list. If you like, if open source affinities make sense to you, then we encourage you to have a look at Project Tortuga. And in fact, let us do more than just encourage you. What we'd love to do is have you contribute to Project Tortuga, as that's really why it was very important for us to open source that particular project. If you need something that's more enterprise grade, then of course our own Navops launch is a compelling capability, and I think that the two use cases that we shared today certainly make it clear as to the kinds of things that you can realize very effectively today. In fact, speaking of rapid introduction of cloud capabilities, both are we have a couple of offerings, one via the AWS Marketplace and another via Oracle Jumpstart, that will, and in fact even what we're talking about in the case with Uber Cloud is these are all ways to really accelerate your introduction of various cloud capabilities in a variety of different ways. You can go from doing really complete proofs of concepts and so on to full-blown production implementations, and these are also great places to kind of whet your appetite, cut your teeth, et cetera, and so on. The path is not one that is completely untrodden. There have been organizations who've gone before you. We alluded to Wharton and also IHME, and we will be sure to follow up with that pointers to those particular case studies in our follow-up email. And with that, I'm going to ask Gary to rejoin me, and let's see how we're doing in terms of questions.
Brilliant. Thank you, Ian. Reminder that this is the Q&A, so feel free to type in some questions. I see some have already been typed in. We will be looking at your questions and passing those over to Ian. In the meantime, I'm going to pick the first one there, Ian.
All right.
So someone's asking the question, Tom, To be clear, I could take Project Tortuga and integrate it with some other workload manager if I wanted to.
Yeah, absolutely. We have provided the core capabilities with Tortuga. We have, in fact, maybe I'll just quickly see if I can go back to that slide. We have provided a basically a kind of a representative implementation with a kit for Univa Grid Engine. So you can see here. And so this really would allow you to have the basis for integrating with some other workload manager. And, as I say, we put this out there because what we want to do is try to accelerate this transition, and contributions are extremely, encouraged and a huge part of that.
Okay, thank you. And a follow-on question is, can you describe a kit a little more in detail?
Yeah.
In particular, what can I use, and can I add stuff into a kit and create my own kits?
Yes, you absolutely can. So let me give a fairly concrete example. Let's take the case of Univa Grid Engine just to illustrate. What you get in terms of a kit is basically the kit includes a ready-to-run version of Grid Engine. The kit includes instructions on how to actually deploy that particular software, in this example, Univa Grid Engine. And then what makes it different than just that sort of application focus is you can tap into the capabilities that are made available via Puppet to actually configure the software in a fashion of your choosing. So what this means, for example, is that you can actually deploy Grid Engine the way that you want to deploy Grid Engine with all of your any customization that you have put in place or seek to put in place can be included as part of the kit. So if you want to add, for example, GPU nodes and configure them according to a specific resource map via Grid Engine, there are a number of steps that you'd want to take, and the kit can automate all of that. So you could do the same kind of thing for any other workload manager, or in fact, any other software.
Thank you. So I have two questions from Angel. The first one is, I know that private clouds were not the focus of today's webinar, but is there an adapter for OpenStack or VMware available with either Tortuga or the product Navops launch?
Yeah, excellent question. We actually, because our focus today was hybrid clouds, and because typically people are making use of the public clouds, we did not say very much at all about OpenStack, but we absolutely do have an adapter for OpenStack, and we have some customers that are making use of OpenStack. The adapter is included in Project Tortuga and also in Navops launch. VMware is also supported as well. In fact, many people regard VMware as their path forward in terms of implementing private cloud, and we have a number of customers who in fact have been doing that for many years. So the adapter is available for VMware as well.
All right, thank you. Second part of Angel's question, which is a follow-on, they have a OpenStack cluster that they would like to use, so this is very positive. The question that he's asking here as a secondary is, he understands that life sciences is ahead of other industries in a cloud adoption, and he'd like to understand why that would be, and is there industries that are just simply not considering adopting?
Yeah, that's a great question, and I think I'm going to go back to one of your slides just to kind of put a little bit of a backdrop in terms of context. I think there are a couple of reasons for that really speak to why the life sciences are where they are at. From an applications perspective, and again, we could talk much more, have a much more fulsome discussion about this, but many of the applications are just, they're briefly, they're cloud friendly, they're serial applications, they're embarrassingly parallel applications. So they're a good fit for the cloud. I think what's also really enabled many of the life science organizations is some of the cloud providers have public life sciences data sets, human genomes or aspects of the human genome, genomes of other, other organisms available in the cloud. So it's really helped to accelerate that adoption. And I think as you were talking, on this particular slide earlier, Gary, for some of these organizations, they've been able to find use cases where they have been able to, address some of the barriers that might have caused concern. So, obviously, some data sets there are compliance and regulation issues like HIPAA and so on. But for certain kinds of research and certain data sets, clearly there has been this significant uptake. Very exciting for us is the uptake that we're seeing in the electronic design automation industry, EDA, on this particular slide here. That is actually a very growing area as we are starting to experience. And as you can see down towards the bottom of the slide here, in some cases, there are some industries that have been slow to adopt the cloud, though again, it's remarkable. But as we continue with our own experience, we're seeing these barriers being, many of these barriers being eroded in various ways. Many of the cloud providers, for example, will have more secure portions of their private cloud that meet the criteria established for government users, for example.
Thank you. One more question here from Watanabe-san. Singularity seems useful for containerizing HPC applications. Will it be supported on your hybrid cloud architecture as well as Docker?
Yeah, that's a great question. We're seeing a lot of interest in Singularity. The short story there is, the really short answer is yes. The slightly longer answer is we already have customers that are making use of Singularity in a Univa grid engine context, and as long as you do something along the lines of making the Singularity images available both in the on-premise environment and the cloud-based environment. In other words, probably what you want to do is make sure you have local to the cloud copies of any Singularity images that you want. That would certainly help to facilitate the use of Singularity as a solution for containerization in the cloud. So yeah, we wouldn't anticipate any challenges really with doing that. We definitely have people that are using Singularity in their on-premise infrastructures, and we might actually already have people who are making use of it in cloud-based environments, but I don't see a huge complication there.
All right, great. So thank you, Ian. There are a couple more questions, but we'll follow up with those after the webinar. The recording for today's webinar will be available for download. We will also be following up with an email with the links to the materials that Ian referenced a little while ago. So with that, we'll pass back a few minutes to everyone's day. On behalf of everyone at Univa, thank you for joining us today.